Chapter is on. Just double check. Yep. All right, so we are in business. It's time to get started. I'll do the same thing. I have to sign into mine first. So sign into your apps account. Okay. Since I signed in yesterday, it kept all the cookies and whatnot, so I'm already in.
Oh, yeah, we have the same one. The same one? And how is that going to be zero?
Go to cisp360, 15 spring, exam 1. There we go.
True, right?
All right, so this is one version of the test. Okay, it's not the only version. It's just one of the versions. All right, so let's go ahead and let me see if I can.
Can we do C, the one we did?
Hmm?
Can we do C, the one we did?
No, because that part is.
Yeah, is that last one?
It's still here, right?
What?
Did you ask? Can you see how you did?
Oh no, I was saying. So there's 3 versions, right?
Right.
Did we as a class do C?
No, we all
Each person
got
a different one. Oh, different one. Okay.
Well, it depends. I mean, it depends. It's all kind of randomized, though. So you might get the same one as another person. You may not get the same one. There's a one yeah. Okay, but they're all very similar. They're all very similar, except for minor little differences. Okay, this is question number 1, or some of you, 1/3 of you, got this particular version. It's just a different number, at certain places, but it really tests exactly the same concept. All right, so let's go ahead and get started with this one. What are the values of the variables x and y as the following expression statement executes? In other words, I'm not just looking at the final answer, but I also want you to tell me whenever something is updated, tell me how it is updated. What is updated to what value? In what order? Okay, so there are 3 whats that you have to answer. And the easiest way to do it is simply to indicate, okay, y gets a value of 5 first, and then x gets a value of 20, and then y gets another value of 60. Now this is really just an example, and obviously that is not the answer. Okay? Okay.
I have a question. If we did y equals 5 as opposed to y equals 5,
that would be fine, as long as I
wasn't
understand.
sure if there was a.
You can use either one.
I might have switched in between just the.
That's fine. Okay, so now the question is, how do you approach this question, right? And you can see the excessive use of parentheses, and that is for your benefit, okay? Because if I do not include, all the excessive, parentheses, you might ask, oh, but, is the priority of the comma higher or lower than the priority of addition and stuff like that? So instead of having to answer those questions, I just put extra parentheses, because that way you know exactly what needs to be evaluated first.
Because this
so
closing it here. That's why I was like, well, if we are closing this here.
Okay, so you guys ready? Okay. So that means we have to start with the innermost parentheses. This is a comma separated expression. It is an expression. Comma is an operator. Okay? And that was briefly discussed when we talked about post increment. Okay, when you look into the post increment, notes, that's when we started to talk about. Oh, by the way, there's a comma, operator, which is really just used to separate expressions. Only the last one matters. Okay, unless each one has a side effect. Okay, so in this case, 5-2 is a comma separated expression, but only the last one is going to present the value of the overall expression. So this means this entire thing is just 2. This entire thing is 5. 2 plus 5 is 7. So in this case, the first answer, if I were to use my own notation, would be x gets a value of 7 first. And then, because this whole thing is one expression. And once again, we have another comma separated expression here. It is nested. So the next expression we have to evaluate is this one here, x plus equal to 5. Now that will update x itself to be 5 more than what it used to be. Since it is now 7, it means x becomes 7 plus 5. And if you give me something like this, fine, I'll take it, not a problem. Okay, just in case you're not sure about your arithmetic and you don't want to risk losing any points, that is 100% acceptable. This is not an arithmetic class. Okay, it's a programming class. As long as you can show me, oh, okay, I think it is the sum of 7 and 5, that's fine. If you tell me it's exactly 12, fine too, okay? Not a problem. And then what will happen is this expression has a value, okay? It has two things to do. One is it updates x. X becomes 12, and then the second thing it does is it also has a value as an expression. The value of this expression is the value that you use to update x, which is also 12. But since this is the second or last expression of this comma, it also means this entire right-hand side of the assignment operator here is also 12. So that means the last thing we do is to say y is also going to get a value of 12, or 7 plus 5 if you want. So that's the answer of this particular question. And the update has to be in this particular order. Any questions about this one? So the alternatives, I think, is the 5-2 instead of 5-2. Some people get 5-4 or something like that. You can actually look at x1a, x1b, and x1c and find out the differences between the three versions. Okay, this is question number 2. Question number 2, I do not need you to show me the steps. I just want you to tell me after everything is done, what is x and what is y. Okay, so now once again we have a comma separated expression. Okay, the comma is an operator. Okay, it is not. It's an operator. Okay, it separates expressions, but only the last one returns a value for the entire expression. So the first expression is going to be this one, which is a ternary operator. A ternary operator has 3 components. The first component is a condition, and then if that is true, we evaluate the second component. If the first component is false, we evaluate the third component. That's basically the behavior of a ternary operator. You were told that x has a value of 45, and 45 mod 2 is the remainder of 45 divided by 2. And what is that?
1.
Exactly. It's non-zero. All we need to know is it is non-zero. Okay? And I'm hoping no one in this class needs a calculator to find out that 45 divided by 2 has a non-zero remainder. Because in that case, this would be the wrong class for that person. I mean, you got to know your arithmetic and how to do things before you tell a computer to do the same thing. Okay? So that means x mod 2 is 1. 1 is non-zero. If it is non-zero, we evaluate the first component. I mean the second expression. So in this case, the second expression is a post-decrement. Now, whether it's a pre-decrement or post-decrement actually does not matter in this case, because nobody cares about the value of the ternary operator anyway. Okay, it's not used in an assignment operation or being passed as an argument. So that means we only really care about the side effect of x minus minus, which is x becomes 1 less than what it used to be. So x started off with a value of 45, it now becomes 44. Is that okay? And we are basically doing the same thing with y, except y has a pre-increment, and once again, whether it is pre or post doesn't really matter in this case. Y has a value of 72 to begin with. So that means 72 divided by 2 has a remainder of 0. This expression is 0, which means we now evaluate the third part of the ternary operator, which is just y itself. Does that change y in any way? Nope. So y gets to keep its old value, which is 72. So the answer is x keeps its value of 44, y is, excuse me, take it back. X is decremented to 44 from 45, and then y is keeping its old value of 72. All right. Any questions about number 2? The variance has to do with which number gets incremented, which one gets decremented, and whether it's a pre or post. Okay, so none of that really matters because if you know how to increment, you know how to decrement. So I don't think it really changes the difficulty of the questions. Number 3 is asking what are the values of variables x and y after the following expression statement executes. Assume x and y are both of integer type, 32-bit, assume x has a value of 45 to begin with, and y has a value of 72 to begin with, prior to the execution of the following statement. Same kind of format as the first four questions to share about the same format. Okay, so once again we have a ternary operator indicated by a question mark and a colon. This is the first component, the first expression. The first expression is not a comparison because of the use of a single equal symbol instead of a double equal symbol. So this is not checking whether x is 32 or not, it is changing x to 23. So the first thing is x is now changed to 23, but that's only one part of what this expression would do. The second part of what this expression does is it has a value, right? Every expression has a value. X equals 23 has a value of 23 itself. Is that okay? Is 23 0? 23 is non-zero, right? So since the first expression is non-zero, we evaluate the second expression, and that becomes the value of the overall ternary operator. But by this time, x is already 23, right? So that means this entire thing is 23, which also means x gets a value of 23, y also gets a value of 23.
What?
I got that one.
Oh.
Yeah. Well, I did warn you guys that, if you miss a equal symbol in a comparison, it becomes an assignment operation, which completely changes the nature of the expression. Instead of checking something and not changing either side, it would use the right-hand side to update the left-hand side. And then whatever you use to update the left-hand side also becomes the value of the assignment operator itself. Okay. Yep, that happens. Okay, it actually happens in programming as well. Okay, some people would make this mistake when they're writing programs, and the effect is something that is unexpected, like this one. All right. Okay. Well, it's only 2 points, so I wouldn't sweat about this one too much.
That adds up, actually.
It's 2 points out of many, because some of the other questions have a lot more points. Like the next one. The next one is worth 10 points. Well, it's worth 10 points because we have to do base conversion and then do the bitwise operation and stuff like that. And I'm trying my best to break it up into multiple parts so that if people cannot get to the final answer, hopefully they can still get to some of the partial answers. Okay, so the question is asking, what are the values of variables x and y after the following expression executes? Blah, 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 same kind of stuff, except this time we use 37 and 48 because I did not want to use the same two numbers as in the practice test in this case, because I want you guys to do the base conversion here, not reuse the base 2 binary representation that we already worked on during class. It's the same approach, I looked at both of these values, they're not difficult to convert. Okay, I did not pick something that was difficult. Just so that you can get partial credit, follow the steps, okay? So the first step is to express 85 as a sum of powers of 2. Okay, this is an example, which means it is not the answer. Definitely not the answer, okay? All right, so let's take a look at 85, and express it as a sum of powers of 2. It has a 64 in it, right? Because 64 is less than or equal to 85, and 64 is a power of 2. Does it have a 32 after the 64? No. What else is in it? It has a 16, right? After the 64 and the 16, we have 5 left. 5 includes a 4 and a 1. Yep. Okay, so that is 85, as a sum of powers of 2. Okay. Now you can do this entire question. If you get to the powers of 2, you can do this entire question without looking at a binary number whatsoever. But this does make it easy to convert it into a binary number as well, so you can match up the positions more easily. The next question is asking what is 85 left shift by 1 bit. Okay, so we are shifting everything to the left-hand side by 1 bit, which has an effect of doubling. Okay, so if you know that part, you can just basically say, oh, okay, we're just going to double all the powers of 2 from the previous question. If you're not familiar with that aspect of left shifting, you can just go ahead and convert the first number into a binary number, add a 0 to the least significant end, and get rid of one of the zeros at the most significant end. Yep.
So if for that one, if somebody just converted to the base 2, is it going to be full credit or?
If you express it in base 2, assuming it is the correct representation, you can still get full credit. All right, next one. Express 37 as a sum of power of 2. That would be 32 plus 5, so that would be 32 plus 4 plus 1. And then 48 is actually the easier one, which is 32 plus 16. Okay? So if you get to this part, you know, if you get any part right, okay, you get partial credit for that part. And now it's time to, you know, finish the whole thing, right? So now we have to figure out what is bitwise AND. Okay, so we have to do the bitwise AND between X and 85, and then we have to do the bitwise AND between Y and, you know, this number here, and then we have to do the bitwise OR and so on. So I'll go ahead and do this step by step as well. Okay, so I'm going to use up some space here. All right, so X and 85 is the same thing as, okay, what is X is 32 plus 4 plus 1, ampersand 64 plus 16 plus 4 plus 1. So when you look at the truth table corresponding to bitwise AND, it basically says you can only end up with a 1 in a binary number if both numbers have a 1 for that particular bit position. But each bit position is really a power of 2. So when you break it down into a sum of powers of 2, it simply means if both numbers have that particular power of 2, keep it. But that's the only time you keep it, all right? So in this case, we can see that, oh, 1 is on both sides, so you keep the 1. 4 is common to both sides, you keep the 4. And then there's nothing else, okay? Because with 16, it is only in one particular number. 32 is in the other number. 64 is also in the first number, in the second number only. So in this case, we only get to keep 1 and 4, which means this expression evaluates to just 5, okay? And then we do the same thing with the other one, which is Y ampersand 85 left shift by 1 bit. This is basically saying the same thing, well, something similar to what we just talked about. It is 32 plus 16 for Y, and it is 128 plus 32 plus 8 plus 2 for the other one. And you get to keep a power of 2 if it is common to both numbers. 32, I can find it in both numbers, so we get to keep it. But there's nothing else, right? Because 16 is only in the first number, 8 is only in the second number, 2 is only in the second number, 128 is also only in the second number. So 32 is the answer. Is that okay so far? We're not quite done yet, okay? We have one more step to go.
Yeah.
Well, 2. 2 more steps to go because we have the assignment here, okay? So Y gets updated to Y and 85 left shift by 1 bit. So that means, you know, Y has a value of just 32 here. X is a little bit more complicated because we have to figure out what this value is, and then do a bitwise OR. So the bitwise OR is like this, okay? So the bitwise OR is basically 1 plus 4 on one side, bitwise OR 32 on the other side. And with bitwise OR, it is kind of the opposite of bitwise AND. If a power of 2 is present in at least one of the two numbers, you get to keep it. Okay? So that means 1 we keep because it is on one side, 4 we get to keep it, and 32 we get to keep it. But none of the other powers of 2 should appear in the result. So that would become 1 plus 4 plus 32, and that adds up to 37. Yep.
Is it accidentally in this example that the value of the x is equal to the value of the x that you already given in the example? Or not?
Oh, you mean this 37?
Yes.
It's supposed to this 37? That's just completely coincidental.
Okay.
Yep. But it is 37. You got it? Good job. Good job. But it does take a little bit of time to get to it because there are multiple steps, and that's why this question has 10 points, because there are many more steps involved in this particular question. All right, moving on. And okay, 37 is in X and 32 is in Y. All right, question number 5. Question number 5 has 6 points, which means it's kind of intermediate, kind of medium in terms of difficulty. In the exam, I gave you the bitwise exclusive OR, okay, which is kind of troublesome because you have to convert everything into binary first and then look up the table and do stuff like that. This one is supposed to be easier because it's just adding and subtracting, right? All right, so what we'll do is we use the same format as last time, and we'll have to detail which variable is updated first. Now, because this entire thing is just a really, really long comma-separated expression, which means we have to evaluate the expressions, sub-expressions, from left to right sequentially, one after another. The first one is this one, okay? Now, since we already know x has a value of 45 and y has a value of 72, so that means the first update is going to x, and x becomes whatever it has already, but we also have to add the value of y to it. Now, if you want to leave it the way it is like this, that's fine, not a problem, okay? The second update is in the second sub-expression, which is this one here. So y is going to be updated already, x, okay, I take it back. Y at this point is still the same value, which is 72, but x has updated already. So you cannot just say that x is 45. X is actually 45 plus 72. Now you can simplify this whole thing and say, oh, okay, we know what this is. Okay, use double equal symbol. Because this 72 is going to cancel out this 72 that is in parentheses after the subtraction. So we really only end up with negative 45 in this case. But we're still doing okay so far with the second update, which is occurring to variable y. The third update is this one here. Okay, the asterisk symbol is multiplication, and when you multiply something by -1, you're basically just flipping the sign of that particular number. So the third update is occurring to y, and y gets the flip side of -45, which is just in 45. And then the last one is not an update, okay? The last one is just an expression, okay? It's just an expression, which is x minus y. At this point, x has a value of 45 plus 72, and we want to subtract y, which is 45 from it. 45 plus 72 minus 45 is 72, okay? But we don't have to write anything here yet, okay? Because that becomes the value of the entire right-hand side of this particular assignment operator, and as a result, x equals 72 is the last step here. Okay? Now, obviously, if you give me the exact number, which is 117, I believe, for 45 plus 72, obviously that will be considered correct as well. But this way is actually easier because you can actually see how the values are canceling out without having to rely on a calculator to do all that. But what is the end result of doing this? We exchanged the values of the variables. Kind of the same effect as the exclusive OR operator, except in this case I'm just using addition and subtraction to do the same thing. All right. Question number 6. Question number 6 is worth 8 points, so it's kind of on the high side, but still not 10 points, which is the maximum. The next one has 10 points. So question number 8 asks you to consider this entire program. Okay, so this is an entire program, and I already identified there are 3 invocations of f, because this is one, this is another one, and this is another one. Okay, but the invocation has to occur in this particular order because I said you have to evaluate from left to right when you evaluate arguments in the function call. So when you are trying to deal with this function call, you cannot do it yet because you have to figure out what is going into the first parameter and what is going into the second parameter. The first parameter is using the value after the first invocation of f. This is using the value of the second invocation of f. Once you have these two values evaluated, then you can have the third invocation of f. Is that okay? The ordering? Okay. So in terms of the answer, the first one is basically just x and x minus x in this particular case. So x starts off with a value of 2 because of the assignment operator here. So it has 2 on one side, and the other side is just 0 because x minus x is always 0. Okay. And then you have to go into the subroutine and find out, okay, if the first parameter is 2 and the second parameter is 0, what is the return value? What is it going to return? In this case, because x is 2, y is 0, at least one side of the conjunction is a 0, which is a false, so that means the entire conjunction is false, exactly. When the first expression is false, you evaluate the third expression, which is this one here. X is 2, y is 0, x plus y is just 2. So the answer to that is 2 here. So we know this part is 2, but remember there's a minus 2 here, so you got to remember that part when you feed it into the third one. So in the third one, that becomes a 0. I'm hoping you guys did not miss this little part here. Okay, the second invocation is this one here. X is still 2, right? So in the second invocation, we have 2 and 2 as arguments to the parameters. So now we go to the subroutine f. We have 2 here. We also have 2 here. 2 and 2, this is logical and, is what? Is non-zero. Very good. It's just non-zero. All we care is whether it's 0 or not. If it is non-zero, we evaluate the second expression instead of the third one. 2 times 2 is 4. And that's why the return value is 4 here. And that one goes straight, at least in this particular version, it goes straight into the second parameter of the third invocation of f. So this one becomes 4. And then you plug 0 into the first parameter, 4 into the second parameter. It will go to the third case here. 0 plus 4 is just 4. So that means this is also going to return 4. Any questions? Yep.
So the thing I'm confused on is like you don't actually read this left to right. You read it from inside out.
Yeah.
Okay.
It's just like with any type of operation. You always, because in order to figure out the last one, the outer invocation of f, you have to figure out what is inside first, right? It's no different from doing something like this in mathematics. Okay. So let's say in math I define f, x, y to be, I don't care, x plus 2y. Okay. So if I give you f of 1, 2, comma, f of 2, 3 plus 5, how are you going to do it?
I'm going to do the inside first.
You have to do the inside first. It's the same exact way.
Okay.
Yep. All right. Are you guys ready to move on to the last one?
Yeah.
Yes.
Okay. There's still enough juice left? Okay. The last one does take a little bit more juice. Okay, so, I still have to answer this question. X gets a value of 4, which is the result of the last invocation of f. All right. Question number 7. Okay, this is the fun one. Well, it's fun, but it's not really that fun because I did not ask you to show me all the steps. Now that would have been a little bit more fun because you have to waste a lot of time to write out all the things. But the way I structured this question is to help you guys to get 1, partial credit, and 2, figure out what it is going to do. Okay, as you work on this one, I'm hoping you guys see, oh, so that's why, blah, 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 blah. Okay, so we'll figure out what this is. Okay. At first glance, this is really difficult because it is recursive, okay? So once again, we have to do with recursion, calling the subroutine that you're already in. But what you need to do is really just to go ahead and do it, okay? And figure out, step by step, mechanically what this is going to do. The first invocation of f is passing 3 to the first parameter and 4 to the second parameter. So x is 3, y is 4. 3 is less than or equal to 4 is
True.
is true.
So it's non-zero.
It is
We gotta choose the-
non-zero.
So we gotta choose the first.
So that would pick the 0 here,
Yeah.
okay? So that 0 becomes the result of the first part of the addition. Okay? So, okay, no recursion. Great. What about the second part? X is 3, y is 4. How do you represent 3 as a sum of powers of 2? 1 plus 2. Right? How do you represent 4 as a sum of powers of 2? Come on. 4 is already a power of 2. Okay? But are they common? Are there any common powers of 2 between x and y? X is 1 plus 2. Y is just 4. Is there anything in common? Nothing in common. Okay. So if there's nothing in common, this expression evaluates to a 0 because there are no powers of 2 in common. And as a result, we use the third expression, which means the entire thing is just a 0. Yep.
So I think what I did wrong on this problem was that I considered the whole plus x and y thing as part of the false statement for the ternary
Yeah, that's
operator.
what I did
What?
too.
I considered like the second statement as part of the false statement for the first ternary operator.
Just because of the parentheses, they got confused with.
Yeah, we didn't see that outside set of parentheses, so it's either it equals 0. or
Oh
it
man,
equals
that
plus.
is opposite to the intent of using parentheses.
I know.
Because I intentionally
There's
use
so
the
many
parentheses to
parentheses
make
that
sure
go.
that this paren here matches that paren over there.
Yeah.
Oh man, that kind of sucks.
That's literally the reason I did that.
Okay. But assuming that you did not read the parentheses, missed the closing one, so let's move on to the second one. The second one is using 3 for the first parameter and using 2 for the second parameter. Okay, so you just have to plug it in and find out what it's going to do. This is 3 and this is 2. 3 is less than or equal to 2 is false. Okay. So if it is false, it goes to the last expression, the third expression of the ternary operator, which is this one here. So x is just being passed as itself, which is 3, but y is being passed as one version of itself that is left shifted by one position. Okay, so what do you get when you left shift 2 by 1 bit? It becomes 1 0 0 in base 2, which turns out to be 4. Okay, haven't we seen this before? F of 3 and 4.
Just a second ago.
That's it. So you don't even have to do it. You just say, we got it figured out already. Okay, so that means this entire thing is just a 0, which also means this entire thing is a 0 as well. However, this side is not a 0 because we have 3 here and then we have 2 here. Okay, we have 3 and a 2, but 3 can be expressed as 1 plus 2, right? 2 is by itself already a power of 2, so 2 is just 2. So when you have 1, 2 on one side and then 2 on the other side, are there any powers of 2 that are in common? The 2, right? So that means the condition is non-zero, which means we pick up the second expression as the value of this entire ternary operator. The first ternary operator has a value of 0. The second ternary operator has a value of 1. 0 plus 1 is 1, and as a result, the second time you update x, it becomes a value of 1. Okay? So knowing that, you move on to the third one. So for the third one, we use we keep using x being 3, but this time y is 1. 3 is less than or equal to 1, obviously is false. So we go here to do the recursion. But the recursion is using 3 here because x is 3, and this time we have y being 1, and we want to left shift it by 1 bit position. What is 1 left shifted by 1?
2.
Is 2. We have seen this before, right? It's the previous one. So that means we know this part evaluates to just 1, which also means this part evaluates to 1. And then you look at the other side, you have 3 here, we have 1 here. Now we already know that 3 is 1 plus 2, and 1 is 1, but they are in common. The common part is just 1 itself. Does that make any sense?
Can you go through the first part of it again?
Yeah.
The first part of the.
The
where
first
you got
part?
1 for the.
This is 3, this is 1,
Yeah.
so this expression is false. Then we go to the third expression of the ternary operator. This is 3, this is 1 left shift by 1 bit position, but if you left shift 1 by 1 bit position, it becomes 2. And we already know that from the second invocation, so I don't have to do it again. Okay, so that means this part evaluates to just 1, right? And so this entire thing evaluates to 1. On the other side, we have 3 and 1 here. Because 3 is 1 plus 2, this is just 1. They do share 1 power of 2, which is 1. 1 is 2 to the power of 0. Okay? Nonetheless, it is a power of 2. So this means the bitwise AND will give you a non-zero result, which also means we have to pick up this value as the value of the ternary operator, the second ternary operator. So we have we have 1 on this side, we have 1 on this side. 1 plus 1 is 2. So the answer is 2 here. This is the one, I'm hoping by this time you guys kind of pick up, what the function is really trying to do. It's trying to count the number of ones in a binary representation. That's all it's going to do.
So it's 3.
Nope, 5, it has 2 ones because 5 is 1, 0, 1 in binary. So it will pick up the 2 ones and add them together. So the answer is 2. Yep. But you can also go through the whole recursion thing and work out that way too.
Well, that's not ours
It's almost there.
Sorry?
It's like
What?
we were assuming completely different things about this function.
What did the function on test C, I think?
Okay, let's take a look at the version C here. So this is version C.
I think it was C.
Okay.
I'm not even sure.
They're
mine.
all very similar. Okay, the differences are very, very minor.
Yeah, well, ours shifts the X
Right.
to the right. Does
Right.
that also count digits, the binary digits? Or
It will still be
or-
counting the same binary digits because if you right shift X, you're basically, you're keeping Y at the same position, right?
Yeah.
But you're moving X in this direction. So relatively speaking, you're still moving the bits, in this
Okay, so
opposite
one's
direction.
moving I-
So
Y
it should
and
work
I.
out exactly the same way.
Mhm.
It's just that 3.
Meaning they should give the same result.
It's because 3 right shift by 1 position is 1.
Yeah.
So it will, yeah. So the answers will be slightly different. For this one, the first answer is 0. The second answer is also going to be let's see. No, this is going to be a 1 because this will still give you the answer of a 1.
Yeah.
Yeah. And then this one is still going to be a 2 because this is still giving you a 1 and this is already known to be a 1. And then the last one, which is a 7, this one will give you a 3 in this case.
0. All right, I got one of them right.
Okay. Are there any questions? Yep.
I don't want to seem like I'm asking a lot, but can I see the answer? You should answers for test P2 for just that problem.
Okay, sure. Just for this one, right?
Yeah, just for
Number 7. Okay.
Yeah, 7.
All these variants, right? I mean, okay. So this is the one for the third variant. So for the third variant, the only difference is, this is still a 5 instead of a 7, but otherwise it's the same as the last one.
So the 3 answers are the same.
The first 3 will still be the same, which is 0, 1, 2, but the last one is going to be a 2, because 5 is represented as 1, 0, 1, and since I'm counting the number of ones in the binary representation, it will be a 2.
Okay.
Yep. All right, so that's it. Are there any questions? 45 minutes. And that's including, talking about multiple versions of the same questions too. Yep.
So if I did not get this question, does that mean I failed the test?
Well, you signed, and said that you understood the syllabus, right? So I'm going to quiz you on the syllabus instead. What are the breakpoints for the letter grades? Well, it also depends on what you consider as failing, right? Yep. Some people consider A- as failing. It's like, oh man, I just failed a test. What did you get? I got like A-. I'm gonna get chewed up by my mom. Okay, so the breakpoints are 12.5% for an F. So anyone who's getting less than 12.5% of the entire score is getting an F. A D is less than 37.5%. A C is less than 62.5%. A B is less than 87.5%. And anything at least 87.5% is an A. You guys do remember that part? I spent like a good amount of text to describe, what I consider A, B, C, D, F, right? So I'm going to grade the test accordingly, assigning points, using that particular scale. Okay, so people who miss something completely will get a 0. Okay, people who did answer certain parts right, but I think is insufficient. Okay, should not move on to the next class will get a D. People who get enough, and I think, well, you can move on to the next class, but it's going to be a little bit difficult, but nonetheless, it's okay to move on to the next class. It's a C. People who did fairly well, except making some, kind of, careless mistakes, okay? But conceptually speaking, seem to be doing fine, okay? Understanding everything, just occasionally missing, comma here, or stuff like that, or miscalculating, okay? Instead of 117, it adds up to 115 or something like that. That would be a B. An A is basically, perfect score, okay? In a test like this, if someone is answering everything correctly or getting at least a 90%, in my scale, that is an A. That's basically excellent in this class. So that's how everything's going to be graded. And because when I grade it, I assign the points according to that, break up scheme. So that's why, everything just kind of works out.
Can we just have more exams actually?
You want to have quizzes, basically. You want to have short quizzes every class or so, every other class, that do not count for a whole lot of points each one, but they are more frequent. We can think about doing that. Yeah.
I was just actually
No.
It's actually better. It's like better than actually coming to the exam. It's 20%, and then you just like you just face the wall. So
yeah. It's good to have practice, disarming, small bombs first before you get the big one. So that so you can basically test it on small bombs where your protective gear is going to help, and then you work on the actual big bomb where the protective gear is not going to be as helpful, right? Yep.
When you put the grade and
well, this is all going to be graded by hand. My script is not going to be helpful in this case. Well, okay, I take it back. It would be partially helpful because what I can do is I can plug in, well, I can have a script to help me partially, okay, but nonetheless, it will still be done manually. And then what I usually do, which is a very manual labor intensive kind of thing, is I will scan every single paper test with my scanner. And then I'll grade it, from the PDF document. Now the reason why I do that is because I can now do it on any computer. I don't have to bring this big pile of paper with me everywhere I go to grade it. And then second thing is I have a copy of everything, so in case there's a dispute of okay, I wrote this down as my answer, but you only gave me this many points instead of that many points. Fine, I'll look it up. You can lose your test completely, and I have a copy online in the cloud securely. But that takes a lot of time because first I have to destaple, run it through the scanner, restaple, so I can give it back to you as a stapled copy of the test. So that part is the most labor-intensive part, and then after that it's just reading the PDF online, on one side, and then grading on the other side. Yep.
Can you go to the time you got one on
Which
the
one?
left side on the first test?
On the first test, this one?
Yes.
And which question?
So say x equals f over 3, 2. How did you get one on the left side so that it was one?
One on the left side. You mean this side here?
Yes.
Because we already know the answer to this. Because this one has a recursion, but when it does the recursion, the new call is just that. It's whatever something that we have seen already. So it will be a 0 on the left-hand side, but it will be a 1 on the right-hand side. 0 plus 1 is 1, and that's why x is updated to 1 in the second call.
So how did on one of them, did we get a 1 on the left side?
Yes, we do. It's the third one.
So how did we get that?
Because in the third one, when we get to this statement, when we do the recursion, it turns out to be the same thing as this one here. But we already know that one is trying to return a value of 1. Because it's recursive,
Okay.
and we have done this already, and that's why I said to structure this particular test or this particular question so that you don't really have to do all the recursive stuff by hand, because you're already kind of implicitly doing it by answering the first question, the first line first. That already sets you up for the last invocation for the second one. So if you notice the similarity, or that you're really doing the same function call, then you say, oh, okay, we have done it already. We know it is 0. And by the time you get to the third one, we have done the second one already. And then you might notice and say, oh, it's the same thing as the second call. We already know the result of that one. So you don't have to actually perform the call. So each one, except for the last one. The last one is testing whether you actually get the meaning of the subroutine itself and go, oh, it is just really counting the number of ones in a binary representation. Now, if you don't notice that, it's okay. You just have to do the recursion and just figure it out step by step.
Okay. Thank you.
Mm-hmm. All right. Any other questions? No other questions? All right. And today is Wednesday, so if you want to do have lunch, that's fine with me. If you want to, and you do have a homework assignment that is active. So if you want to work on your homework assignment, that's okay with me too.
So the ones due Monday. Yes.
That is correct. The homework assignment is due on Monday. All right.
What was the command for making a source file with the directory again in the folder?
Creating a new folder is mkdir,
Right.
make dir. And
what about the source file? Do you just go on Vim from there once you're in the
yeah,
folder?
you can just say vim main.cpp. That will create the file if it is not there already.
Okay.
Yep. All right, I'm going to turn off the recorder. So now whatever